Here we're given a differential equation with initial conditions. We're asked to apply the Laplace transform and solve for big Y of s, which equals the Laplace transform of y or y of t. So we're not actually going to solve the differential equation for y of t, we're only going to solve the differential equation for the Laplace transform of y, which is big Y of s. Remember, to solve a differential equation using Laplace transforms, we follow these 4 steps. Where step 1, we begin with an initial value problem. Step 2, we use Laplace transforms to create an algebraic equation. Step 3, we solve the algebraic equation for the Laplace transform of y, or big Y of s. So for our example, we'll stop at this step. If we did want to solve the differential equation for y of t, we'd have to use inverse Laplace transforms, again, to solve the original differential equation. So for this example, we will not be performing this last step. However, we will look at future examples where we'll solve the differential equation for y of t by performing all 4 of these steps. For our problem here, the first step is to take the Laplace transform on both sides of the equation. So we'd have the Laplace transform of y double prime plus 3 times y prime plus 4y equals the Laplace transform of 0. Now we'll use the properties of Laplace transforms to rewrite the left side. Let's write the left side as the Laplace transform of y double prime plus 3 times the Laplace transform of y prime plus 4 times the Laplace transform of y equals the Laplace transform of 0. And now to find the Laplace transforms, and then to find the Laplace transforms of y double prime and y prime, we'll be applying the theorem stated here, which will give us the Laplace transform of y double prime equals s squared times big Y of s minus s times y of 0 minus y prime of 0, and the Laplace transform of y prime is equal to s times big Y of s minus y of 0. So the Laplace transform of y double prime again is equal to s squared times big Y of s minus s times y of 0 minus y prime of 0. Then we have plus 3 times the Laplace transform of y prime, which is s times big Y of s minus y of 0. Then we have plus 4 times the Laplace transform of y, which is big Y of s, so we have 4 times big Y of s, and the Laplace transform of 0 is 0. For our next step, let's distribute here and clear the parentheses. So we have s squared big Y of s minus s times y of 0 minus y prime of 0 plus 3s times big Y of s minus 3y of 0 plus 4 times big Y of s equals 0. Next, let's substitute negative 2 for y of 0 here and here, and we'll substitute 1 for a y prime of 0 here. So we'd have s squared times big Y of s. Here we're going to have negative s times y of 0, which is negative s times negative 2. That becomes plus 2s. And then here we have minus y prime of 0, which would be minus 1, plus 3s times big Y of s. And then we have minus 3 times y of 0, which would be minus 3 times negative 2, which becomes plus 6. Then we have plus 4 times big Y of s equals 0. Let's continue on the next slide. For next step, let's keep the big Y of s terms on the left and move all the other terms to the right. So we have s squared big Y of s plus 3s big Y of s plus 4 big Y of s equals, we'll subtract 2s on both sides, so we'd have minus 2s, then negative 1 plus 6 is 5, so we'll subtract 5 on both sides, so the right side we have negative 2s minus 5, and now we'll factor big Y of s out of these 3 terms, which would give us big Y of s times the quantity s squared plus 3s plus 4 equals negative 2s minus 5. And now for our last step, we'll divide both sides of the equation by the quantity s squared plus 3s plus 4. So simplifying, we get big Y of s, which again is the Laplace transform of y, is equal to the quantity negative 2s minus 5 divided by the quantity s squared plus 3s plus 4. So while we are done with this problem, keep in mind this is not the solution y of t to the initial value problem. This is the Laplace transform of y, which equals big Y of s. So going back to our first slide, we're only asked to find big Y of s, which we now have. Big Y of s equals the quantity negative 2s minus 5 divided by the quantity s squared plus 3s plus 4. And remember, if you are entering this in from the keyboard, you would want to enter parentheses around the numerator and denominator. I hope you found this helpful.